A parallel plate capacitor A is filled with a dielectric whose dielectric constant varies as per K is equal to B. An identical capacitor B of capacitance C0 with the air as dielectric is connected to the voltage V0 is equal to 30 volt and then connected to the first capacitor after disconnecting the voltage source. The charge and voltage on each capacitor will be equal to. Now I can say that by law of conservation of charges, okay, there is no external part, the only charges are exchanged between the capacitor 1 and the capacitor 2, okay, so the total charge will remain same. So let the initial charges be equal to Q1 and Q2, okay, that is the Q1 on the first capacitor and Q2 on the second. It will be written as C1 V1 plus C2 V2. Now initially it is given that, now let us see C1 and C2. For the first capacitor C1, when it is filled with dielectric, okay, let us first talk about C2. C2, when it is, C2 is constant, okay, that is it is filled with air, let it be equal to C0, okay, let it be equal to C0. C1 is a similar capacitor, that is when I can say when it is filled with air it will be equal to C0, otherwise it will be when it is filled with dielectric it will be equal to K times C0. Now the K varies as per V, so I can write this as V into C0, okay, I can write this as V into C0, okay. So basically C1 and C2 are known over here. When I substitute the values, okay, initially the first capacitor is uncharged, so V1, initial V1 is equal to 0, okay, and V2 is 30 volt, okay. So Q initial charge will be equal to, if I substitute the values, it will be equal to, initially this part is 0, C0 is equal to C2 is equal to C0 and V2 is equal to 30 volt, okay. Let this be the first equation. Now when they are connected in parallel, okay, when they are connected in parallel, then the charges will be exchanged from the, this is the first capacitor, this is the second capacitor. The charges will flow from the second to the first capacitor till the point that both the capacitors attain the same voltage. Let the potential developed across them be V and V, okay. Now the total charge remains same, okay. So Q will be equal to, again, okay, it will be equal to C1 into V plus C2 into V, okay. Now C1, the capacitance is equal to V into C0, okay. Now instead of Q I will substitute C0 into 30 or 30 C0 is equal to, instead of C1 I will write V into C0 or C0 into V square plus C0 into V. So C0 will get cancelled everywhere, V square plus V minus 30 will be equal to 0, okay. So basically this is a quadratic equation, okay. So the resultant voltage will be equal to minus B, that is equal to minus 1 plus minus root of B square, okay, minus 4 AC. So 4 into 120, okay, divided by 2 into A, okay. So it will be equal to, voltage over here will be equal to negative 1 plus minus, it will be equal to root of 121 is 11 divided by 2, okay. So which is equal to, it will be equal to, I will take the positive value of 11 only because the voltage over here cannot be negative because I have already considered the negative term, okay. So over here if the voltage becomes negative, then this part will also become negative, so I will take only the positive value of the voltage, okay. So it will be equal to minus 1 plus 11 divided by 2 which is equal to plus 10 divided by 2 which is equal to 5 volt. So the voltage across them will be equal to 5 volt, across both of them will be equal to 5 volt, okay. So correct answers will be B and C, okay. I will also find the charges, okay, I will also find the charges. The charge on the first capacitor is equal to C0 into V square, okay. So V square will be equal to 5 square which is equal to 25 V square, and on the second it will be equal to C0 into V which is equal to 5 into V, okay. So or 5 into, it will be equal to 5 into C0, okay, it will be equal to 5 into C0, not V square, it will be equal to 5 into C0, and over here it will be equal to 5 into C0, and for the first charge it will be equal to 25 C0, okay, which matches the value given over here. So the correct answers are option B and C.